Hello, and a very good evening to all of you. I hope all of you are doing well. So, in today's class, what we're going to learn about is we are going to learn about class diagram. Now, class diagram is one of the widely used diagram in UML that is capable of modeling the static design view of a system. So, something that does not change with time. Also, it is useful for modeling various business objects that are participating in realization of a business process. Now, it's also useful in specifying the structure, interface, and relationship between various classes. So, this is a very important point that you need to remember. So, it's capable of specifying the structure, interface, and relationship between various classes that underlie a given system architecture. Now, it is one of the diagrams that is used for generating code from UML models. So for an example, you can use tools like Umbrella for creating executable code from a class diagram. Now, let us try to understand what is a class. Now, a class, as we have already studied, is a description of set of objects that share same attributes, operations, relationships, and semantics. So these are the important characteristics that define a class. So a class is a collection of objects that share same attributes, operations, relationships, and semantics. So a class can be defined as a software unit that implements one or more interfaces. So now here what we have is we have an example of a class student where we have a set of attributes defining the class, and we have set of methods. So as we have learned in the previous class, a class has two important components in it. The components are the attribute set and the set of methods. Okay, right? So the attribute set highlights the set of variables that the method operates upon. So in some of the representations, you may also find an optional plus, minus, and hash associated with each of the data member and the member functions. So plus here basically means public, minus here basically means private, and hash basically refers to protected. So these are the access specifiers that are associated with the data member as well as member functions belonging to a particular class. Now, let us try to understand the difference between relations and links. So, when in context to classes, what we do is we say that a class A is related to class B, whereas in case of object, we say an object A is linked to object B. So a relationship is a mechanism that is used to establish a communication channel between two different classes, and a link is a communication channel that is established between two different objects. So we use relationship in perspective to class, and we use links in connection with the object. So this is very much important. So a class is related to another class, whereas an object is linked to another object. So there can be different types of relationship between classes as specified here. So there can be six different types of relationships that may be established between different classes. The relationships are association, aggregation, composition, dependency, generalization, and realization. So these are very important relationships that can be established between different classes. So let us try to understand these relationships with the help of an example and a description. Now, let us talk about association first. Now, association is the simplest form of relationship that can be established between two different classes, and it acts as a communication link between two different classes. So, again, I'll repeat it. Association is the simplest form of relationship between two different classes, which tries to establish a communication channel between two different classes. So, it's a peer-to-peer relationship. So, why do we need to have association? Is because of association, one of the object is aware about the existence of another object. So it lets the object know that there exists another object to which it is related to. Now, there might be different ways in which association may be established between the different classes. So here, just see what I have is I have two different class. I have a class student, I have a class enrollment. So one student is enrolled into one to n number of enrollments. So this is a typical example of association. So it's a simple communication channel established in between two different classes. Now, related with an association, there has to be the associated semantics, because the semantics defines the way how the objects are related to each other, or the way how the objects communicate with each other. And in addition, here what we have is we have the cardinality and the modality ratio that reflects the participation of different objects in the relationship. Now, association can be of different type. Let us just try to understand it with the help of an example. So here, A is physical or logical part of B. So this is a kind of association, or A is a kind of B, right? A is contained in B. Now, next is A is description of B. A is a member of B. A is an organizational subunit of B. A uses or manages B. A communicates with B. A follows B. A is owned by B. Just see, these are instances in which the objects may be related with each other. So you see, these are the various ways in which what you can do is you can have an association being established between different classes. Now, let's talk about the next kind of relation that you have, that's called as aggregation. Now, aggregation is a restrictive version of, or restrictive form of association, which tries to represent part of relationship, right? Okay, so for an example, pages are part of a book, right? Okay, so paragraphs are part of a page, lines are part of paragraph, words are part of lines, characters are part of word. So that is the way how what we need to do is we need to represent aggregation relationship. So aggregation is a restrictive form of a part of association, right? Again, so it tries to represent part of association or part of relationship. So objects are assembled in order to create a more complex object. So if I say that a book is a collection of pages, so book is a complex object, whereas you can consider pages to be a very simple object, right? Okay, so it basically tries to resemble a physical or logical assembly of objects or classes. So here, say for an example, if I say that a book is a collection of pages, so it basically represents physical assembly of pages, right? So it can be physical or logical assembly. Now it defines a single point of control. So here, just see, using aggregation, what we can do is we can define a single point of control. For an example, so for an example, if I want to hand over a set of pages to an audience, so what I can do is, if I hand over the book, then automatically what I have is I have handed over a set of pages to the recipient. So this implies that what I'm trying to do is I'm trying to define a single point of control. So instead of handing over a collection of single pages, what I'm doing is I'm handing over a book that will create a single point of control for handling all the pages. So that is the reason why we need to have aggregation. So aggregation defines a single point of control for participating object. Now, the aggregate object coordinates its parts definitely, right? So if I try to handle the book, I'll be trying to handle the set of pages. So that is the way how aggregation is actually very crucial, because it's capable of representing assembly in order to create a complex object from a set of simple objects, right? So the assembly may be physical or logical, so it defines a single point of control. So here, just see, there's a typical example. So here, an order has, so a particular order has 1 to n number of order details, right? So for an example, or a book has 1 to n number of pages, or a page has 1 to n number of paragraphs. A paragraph may have 1 to n number of lines, where each line will have 1 to n number of words, where each word will have 1 to n number of characters. Now, just see, that's the way how what we can do is we can define aggregation. Now, the next important relationship that can be established between classes called as composition. Now, a composition is a very stricter version of aggregation, that is existence dependent. So, for example, if the book does not exist, then the pages does not exist. So, a relationship of that kind. So, it's a stricter version of aggregation. that tries to represent existence dependent relationship, that is the lifespan of the individual object depends on the lifespan of the aggregate object. So if the book is not there, then the pages will not be there. So that kind of relationship. So if the parts cannot exist, I mean the parts cannot exist on their own. So this is an important statement that we are trying to that we have made here. So individual parts cannot exist on their own, so it has to exist as a whole, right? So there is a delete dependency of the part to the whole. So if the whole is deleted, then the parts are also deleted. So composition is a very restrictive version of aggregation that tries to represent a existence dependent relationship. So if the whole exists, then the part exists. Otherwise, the parts cannot exist independently or individually. So here I have an example. If the order exists, then what I have is I have the order details existing there. So if there is no order, then there is no order details. Now the next type of relationship that we have is called as dependency. Now, as you know, dependency is a relationship that is established in between a dependent class and an independent class. And how do we define dependency? Is that if any change brought to about in the independent class, the necessary changes are being reflected in the dependent class. So here, client is the dependent class, and the supplier are the suppliers are the independent class, or supplier is the independent class. So any change that is brought about in the supplier, implicit change will be enforced upon the client. So so dependency is a semantic relationship between two elements in which a change to one of the element may affect the meaning of another. So where you are bringing about a change, you are bringing about change in the independent element, right? Okay, as a consequence of change of the independent element, what we have is we have the dependent elements being changed. So that is the way how the dependency relationship is established. So if you bring about a change in the independent entity, the necessary change may be reflected or brought about in the dependent entity. Now, the next relationship that we have is called as generalization specialization relationship. Now, generalization specialization relationship is a relationship that is established in between a base class and a derived class, or a set of derived classes, right? Okay, so a relationship in which object of a specialized element are substitutable for objects of a generalized element parent. So it's a generalization, it's a relationship that is established in between base class and a derived class. Now, for an example, let us try to understand it with the help of an example first. Okay, before that, let's try to discuss. So, the child element shares the structure or the behavior of the parent, right? So here, what I have is I have a set of derived classes, that is payment through credit card, payment through cash, payment through check, and payment through wire transfer. So now here what I have is I have a base class that is called as payment. So payment is a base class that is a generalization of all the derived classes. Now just here, whatever is common between pay via credit card, pay via cash, pay via check, and pay via wire transfer is the definition of the base class. Whereas specialization relationship is interpreted in this manner. Each of the derived classes are nothing but the specialization of the base class. So here just see generalization specialization relationship is equivalent to kind of or a type of relationship, right? Okay, so credit pay via credit card is a type of class that is payment. Pay via cash is a type of class that is payment, right? Okay, whereas payment is a generalized version of all the derived classes. So a specialization is opposite to generalization. So that is what is generalization specialization relationship. So generalization specialization relationship is a relationship that is established in between the base class and the derived classes, where the base class is a generalized version of the derived class, and derived classes are specialized version of the base class. So now the next relationship that we have is called as interfaces. Sorry, realization. Now realization is a relationship that is established in between the class that actually requests for an activity, and a class that actually provides the support for that particular activity. So it's a semantic relationship between elements wherein one of the elements specifies the contract. That means one of the element requests for an activity, and the other element guarantees to carry out that particular contract. So that is the relation, that is the realization relationship. So it's a relationship between one who requests for the activity and the one who provides support for the activity. So if you consider this particular example here, what we have is we have a realization relationship between an object that is called as bank or account business rules, and an object and a class that is called as rule agent. So rule agent is capable of providing all possible support in regards to the rules that are associated with creating a business account, right? Okay, so here what we have is we have a class requesting for services of another class or another class. So here account business rule is a class that is requesting for the activity that is performed by I rule agent, right? Okay, so in a banking system, yeah, so there may be an object that may be requesting for the information regarding the rule, and there might be an object that is capable of providing support to that particular rule. So realization is a relationship that is established in between, and between the one who specifies the contract and one who provides support for providing solution for that particular contract. So it is graphically rendered using a dashed arrow. So it's represented here. It's graphically rendered using a dashed arrow with a hollow arrowhead. So it basically it's a relationship, right, between the one who specifies the contract and the one who provides support for the contract. So contracts are nothing but an alternative use for activities. Now here the next concept that we need to discuss is superclass and a subclass. So this is a very simple concept. Superclass is a class that contains the feature common to two or more classes, right? So that's called as a superclass, right? Again, and subclass is a class that contains at least the feature of its superclass, right? So that's called as subclass and superclass. So now the next thing that you need to understand is the class notation. Now there are various ways in which classes may be represented, right? So a class may be represented with the help of elaborate notation. It may be represented with the help of a suppressed notation. So here in there are two ways of representing class. So in one of the notations, what we have is we have the class represented in terms of three compartments, where we have the class name, we have the attribute list, and we have the behavior list. And the other case, what we have done is we have suppressed the attributes as well as we have suppressed the behavior. So depending upon the availability of the attributes and the set of operations, what we can have is we can have either a detailed notation or elaborate notation, or what we can have is we can have a suppressed notation of a particular class. Now, this is a typical example of a class diagram. So here what we have is we have various classes participating in a realization of the business. So here what we have is we have the classes student, we have class seminar enrollment, we have class seminar, we have class course, we have class professor, and we have class address. So there are various classes that are participating in realizing the business, and each of the classes are elaborated with the help of attributes and the set of methods that are capable of working on the values of the attributes. Now, here, let us try to understand this particular class diagram. So here I've taken the class diagram from the web reference, from one of the web reference, right? So here, let us try to understand the classes and the relationship between various classes. So let us try to take the student class first. So student has set of attributes and it has set of behaviors, right? So let us first try to establish relationship between seminar enrollment and student. So one student enrolls in 1 to n number of seminar enrollments. So there might be n number of seminars that may be floated at a particular point in time. So one student may enroll into 1 to n number of seminars. Now there might be 1 to n number of enrollments for a given seminar, right? So n number of students may have enrolled into one particular seminar. So just see, what we have done is we have established relationship between seminar enrollment and seminar as well. So one student may enroll in 1 to n number of seminars, and there might be n number of enrollments belonging to a particular seminar. Now, between seminar and student, so there might be, so it may so happen that students may be placed in waiting list. So if the number of enrollment exceeds the limit, so what we need to do is we need to place the students into the waiting list. So 0 to n number of students may be placed in the waiting list. So right, so there might be 0 to 1 number of seminars for which what we can have is we can have waiting list, where there might be 0 to n number of students. So it may so happen that some of the seminars you may have exceeding number of enrollments, right? Okay, or the enrollment may exceed the limits. So in such situation, what we need to do is we need to generate list. So there might be 0 to n number of students in 0 to in the waiting list for 0 to n number of seminars. Now the next relationship that we need to interpret is between the student and address, right? Now 0 to 1 number of student, a 0 or 1 number of student stays in one particular address, right? So this is very true. So you can say that 0 to 1 number of student lives at a particular address. Likewise, 0 to 1 number of professor lives at a particular address, right? Okay, now 0 to 1 number of professor mentors 0 to n number of associates. So there might be a set of people in the teaching fraternity that may be mentored by their seniors. So 0 to 1 number of professors may mentor 0 to n number of associates, right? So likewise, 0 to 1 number of professor instructs 0 to, 0 to n number of seminars. So it may so happen that a seminar may be a seminar, so there might be n number of seminars a professor is capable of deliberating lecture in. So 0 to 1 number of professor instructs 0 to n number of seminars, right? So that's the way how what we need to do is we need to interpret the relationship. So likewise here, what we have is we have 0 to n number of seminars being offered for one course. So it may so happen that if you consider uh, if you consider a particular subject, artificial intelligence, so there might be 0 to n number of seminars for one subject, that is artificial intelligence. So 0 to n number of seminars are being organized for a particular subject. So that is the way how class diagram is to be created. So in this particular class diagram, what we have done is we have identified the classes that are participating in the realization of the business. We have identified the attribute set, we have identified the behavior set, as well as what we have done is we have created an association between various classes, and we have associated the semantics with each of the association, that is the meaning of relationship, and we have associated the cardinality and modality relationship as well, that is the participation ratio, right? So in this class, what we have learned about is we have learned about we have learned about class diagram. We have learned about what is a class. We have learned about the various types of relationship that may exist between classes, right? We have learned about different ways in which association can be expressed. We have learned about aggregation. We have learned about composition. We have learned about dependency, generalization, specialization. We have learned about realization relationship. We have learned about superclass and subclass. We have learned about the class notations, the detailed notation, and the suppressed notation, and then we have taken up an example from a web reference in order to understand the building process of a class diagram. So in the next class, what we're going to do is we're going to continue with object diagram, and then subsequently the interaction diagrams. Thank you very much.